war in the Malware.
Welcome to the first episode of MalWar. It's a war where the malware has conquered all digital devices and computing devices. This is the first episode of the malware, and in this episode, we're going to be talking about the malware itself, a great malware, and of course, what does the malware do? It breaks down systems. So we're going to be talking about malware breaking down systems, and for a malware to break down a system, it has to have some certain characteristics, which I call the greatest characteristics of a malware, and we're going to be covering all those characteristics today. At the ending, or towards the ending of this video, we're going to be creating our own malware, and all these characteristics are going to be embedded into the malware. So stay tuned to the end of this video, and if this is your first time on this channel, subscribe and hit the like button. Share the video for more cybersecurity tips.
The question is, what are the best characteristics of a great malware? Now, if you don't know what a malware is short for malicious software. It encompasses a variety of programs designed to infiltrate, damage, or disable computers and networks. Understanding its key characteristics can aid in the detection and prevention. There are several characteristics of a great malware. In today's video, I picked out the core characteristics of a great malware. Now, you should know that while creating your malware, these characteristics are the core characteristics you should take note of. Quickly, the first on my list is self-replication. Now, many malware types, such as viruses and worms, can replicate themselves to spread across systems. Worms, for instance, can propagate without users' intervention, exploiting vulnerabilities to infect other devices. The second on my list is stealth and concealment. Now, malware often employs techniques to avoid detection. Rootkits, for example, can hide their presence by modifying system processes and files, making them invisible to standard security tools. I've got polymorphism and code obfuscation on my list as the third. Now, some malware can alter their code structure without changing functionality, a technique known as polymorphism. This makes it challenging for the signature-based antivirus programs to detect them. Now, this is a very core characteristics of a malware. If you have these characteristics in your malware, it is going to be very hard for security softwares to be able to detect your malware. Why? Because over time, your malware changes its structure. Alright, the fourth on my list is payload delivery. Quickly, beyond spreading, malware often carries a payload designed to perform specific malicious actions, such as data theft, file encryption, as seen in ransomware, or system damage. Now, I've got persistence mechanisms as the fifth on my list. Quickly, to maintain access, malware may install itself in system areas that ensure it runs on startup or at scheduled times. Some even modify system settings or use legitimate processes to avoid detection. I've also got command and control communication. Now, advanced malware connects to external servers to receive instruction and exfiltrate data. This communication can occur over standard protocols like HTTP or DNS, making it harder to spot. Now, on the seventh, I've also got exploitation of system vulnerabilities. Now, malware often exploits known or zero-day vulnerabilities in software to gain unauthorized access or escalate privileges within a system. The eighth on my list is data exfiltration. Certain malware types such as spyware and keyloggers are designed to collect sensitive information like passwords, credit card numbers, or personal data, transmitting it back to attackers. Now, there is disruption of normal operations. Now, this is the ninth on my list. Take note of this, it's very important. Malware can degrade system performance, cause crashes, or disable essential services, leading to operational disruptions. Now, if this characteristics is in your malware, this means your malware is very, very great. On the 10th on my list, I've got evasion of security measures. To avoid detection, this malware may disable antivirus programs, alter firewall settings, or mimic legitimate software behavior. At this point, it is very, very hard to detect the malware in the system. Security softwares won't be able to detect the malware, and this is how malware lives in system for so long that you have no choice to start changing the hardware parts of the system. Now, these 10 characteristics I've listed out are the core characteristics of a malware, and if creating a malware, you should take note of these, because of course, why should you create a malware that don't have these core characteristics? Now, I'm going to be listing out a few more characteristics, and I'm going to be writing a malware script. I'm going to write a code for a malware. I'm going to create a malware on this video, live on this video. So stay tuned to the end of this video to see the malware that I'm going to create. I'm going to put in each of these characteristics in this malware. So it's going to be very operational, and yeah, you're going to be coding it with me, so you have the source code. Now, aside those 10 I listed earlier, there are certainly more characteristics of a malware that enhances its effectiveness and stealth. The first here is fileless operation. Unlike traditional malware that relies on files stored on a disk, fileless malware operates entirely in a system's memory. It operates in a system's RAM. This approach allows it to evade detection by conventional antivirus solutions that can scan for malicious files on the hard drive. By leveraging legitimate system tools like PowerShell or Windows management instrumentation, fileless malware can execute malicious activities without leaving a footprint on the storage, making it challenging to detect and remove it. The second is steganography for concealment. Some advanced malware employs steganography, a technique that hides malicious code within seemingly innocuous files such as images, audio, or video files. This method, known for stegomalware, allows the malware to bypass security measures by embedding harmful payloads within files that appear legitimate. You know what steganography is: hiding malicious code or hiding something behind a file, so you can send the file without the user knowing what's behind the file, just like writing a Python script, embedding it in a picture and sending it to someone, and once the person gets the image, the script is running in the background. Once these files are opened, the concealed malware is extracted and executed, often without the user's knowledge. That's how it works, pretty sure. Now, on the third, I also have modular architecture. Modular malware is designed with a flexible architecture that allows it to load and execute different components or modules as needed. Now, this design enables attackers to adapt the malware functionality dynamically, adding or removing capabilities such as data theft, surveillance, or system disruption based on the target environment. For instance, the Taj Mahal spyware framework consists of multiple modules that can perform a wide range of espionage activities, making it highly adaptable and difficult to detect.
Now, understanding these sophisticated characteristics is crucial for developing effective cybersecurity strategies to detect and mitigate malware threats. Now, stay tuned in this video because the next thing we're doing now is creating a malware with the 10 characteristics embedded in it. Writing the code, for some reason, because if you went with me while typing the whole code, the video was going to be extremely long. I didn't want to make the video too bulky for you, so the code, I'm going to drop a link to a GitHub repository where you can get this code, or if you still want to type it alongside, I'm going to be explaining the code line by line for you to understand, so that when you get the code you don't get confused. Now, from the first line, import OS. This line imports the OS module, which provides a way of using operating system dependent functionality. The next line, line 2, imports time. This line imports the time module, which provides various time related functions. The third line, imports subprocess. This line imports the subprocess module, which allows us to spawn new processes, connect to their input/output/error pipes, and obtain their return codes. The fourth line, import C types. Sorry, I've been talking too much. Import C types. This line imports the C types module, which provides C compatible data types and allow calling function in DLLs or shared libraries. Import SYS, short for system. This line imports the SYS module, which provides access to some variables used in or maintained by the Python interpreter. The sixth line, import request. This line imports the request module, which allows us to send HTTP requests using Python. The seventh line, imports base64. This line imports the base64 module, which provides functions to encode data using base64 encoding scheme. Now, on the 10th line, there is a function, define the function hide process. On the 12th line, not certain, I don't want to read the whole line, let's make the video shorter. So on the 12th line, what happens on the 12th line? The line uses the C types module to call a set console title function, which from the kernel 32.dll, which sets a title for the console window. You know the title, like on your apps, the title where the title is seen. Yeah, the title console. That is what happens there. Now, on the 13th line, the line uses C types module to call the show window function, which hides the console window. Now, you don't want the console window showing in your shit like when it's running, so you want to hide it. And on the 16th line, define a function polymorphic code. There, what happens on the 18th line, there is a variable defined there named code, with the content print malware running. Yeah, just print malware running. That's what's happening here on the 18th line. While the 19th line encodes the string variable code using base 64, encoding it and then decodes it back to the string. On the 20th line, the line decodes the base 64 encoded string back to the original string. On the 21st line, the line executes the decoded string as Python code. Come to the 24th line, we have a function defined deliver payload. Now the 25th line has a URL there. Yeah, this line, the 25th line. But we don't have an actual server for now, so or like an actual payload unhosted. So for now, we just use this for now. Payload, we divide the variable, named it payload URL, the URL of the payload file. Like we don't have an actual payload file for now, so we just use this. The response on line 27, are you following, please? The response on line 27, the line sends a HTTP GET request to the URL specified in payload underscore URL, which is 26th line, using the request module, and stores the response in the variable response. On the 28th line, the line opens a file named payload.exe in binary write mode and assigns it to the variable f. Right? Yep. And assigns it to the variable f. On the 29th line, the line writes the content of the HTTP response to the file opened by the binary write mode. Then the 30th line, we have on the 30th line, okay, that line starts a new process executing the payload.exe using the subprocess module. Yeah. Okay, I defined the function persistence in the 33rd line. Now, if you watch and if you observe, I've been following each and every of the characteristics. Now, that is a defined function persistence for the persistence characteristics. Now, the line on the code on the 35th line expands the app data environment and constructs the path to start up the folder. That's what happens there. On the 36th line, the line opens a file named malware.exe in the startup folder in binary write mode and assigns it to the variable f. The line on the 37th line, f.write 6.executable. The line writes the current Python executable to the file opened in binary write mode. That is what's happening there. Alright, come to the line 40. Define the function command and control. Line 42 there's a variable defined server underscore URL with the URL to the server, the command and control server. We don't have an actual server for now, so yeah. While true starts up an infinite loop. This is the 43rd line. Try starts a try block. Okay, response request dot. That line sends a HTTP GET request to the URL specified in the server underscore URL using the request module and stores the response in the variable. Alright, the next line, command equals response dot text. The line extracts the text form of the HTTP response and assigns it to the variable command. If command equals exit, I'm sure we know what the equals is. Is checking if what is on the left is the same as what is on the right. If what is there equals exit, break. This is very simple, right? Yeah. So subprocess.call command shell equals true. The line executes the received command using the subprocess module with the shell equals true option, allowing the command to be executed in a subshell. Now, except start a catch block for any exceptions that may occur during the execution of the try block. Pass doesn't do anything. Like it's the line doesn't do anything in the catch block. It doesn't do anything. Time, this line pauses the execution of the loop for 5 seconds. At this point, the line 55 defined a function named exploit vulnerabilities. Now this line 57 defines a list named vulnerabilities known with two known vulnerabilities. 58 starts a line 58 starts a loop iterating over each vulnerability in the vulnerabilities list, right? This guy starts a loop that checks through this loop. Alright, so there's supposed to be a code to exploit the vulnerability. So I don't want this video to be taken down by YouTube. At this point we have data exfiltrate. A function defined name is exfiltrate data. At this point on line 65 we have data. It's a variable there. It's a list of sensitive data to be exfiltrated, and here the server URL comes up again. Defines a string. It's a string with the server URL, and this line sends an HTTP post request to the URL specified in server URL using the request module, passing the data list as requested body. Alright, so here we define another function, and this line uses the OS module. That's the function defined. This line uses the OS module to execute the task kill command, which terminates the explorer.exe process, which is a process responsible for the Windows Explorer shell. Alright, here is again a function to evade security. This line over here uses the subprocess module to execute the exe command, which is used to manage services in case to disable Windows Defender service. Here I define the function named main, and all this is now the remaining part of this code is quickly to run the code. We call, in Python, after creating all these functions you have to call them again. And if name equals main equals main, if the left and right are the same thing, then we call main, which is this function again, and it runs the code. Alright, a big shout out to you and thank you for being on this channel, and thank you for staying true to this video. Hit the subscribe button, like the video, and share if you gain something from the video. I think somewhere on your screen you should be seeing a video on how hackers do hack people's devices. Do check it out to keep your skill updated.